The environmental and energy transition challenges of the world are becoming more concerning in light of climate change. And it is now clear that new and innovative technologies will be needed. Temperatures are rising around the globe, and it is understood that this could have serious consequences in some places. Extreme and extended periods of heat will transform both rural and urban areas, exposing cities to a rising heat island effect, while decreasing the productivity of agricultural areas. A relatively unknown ability of geothermal and the Eavor loop is cooling. In already hot countries like the UAE, for example, 70% of their current electricity consumption is for cooling, which is required for both residential and commercial purposes. It's used in agriculture for greenhouses and modern technical applications such as data centers. Despite significant growth of renewable energy usage across the Middle East in places such as Jordan and the UAE, the electricity capacity generated by renewables across the region is still only 8%. However, the UAE expects to continue that growth trend to reach 20% of power generation from renewables within the next 3 years. Currently, solar energy accounts for almost 100% of the renewable energy generated in both Saudi Arabia and the UAE. But what about geothermal energy? Despite geothermal's potential cooling applications for agriculture, data centers, and district cooling, there are no meaningful geothermal installations in hot countries around the world. We believe this is about to change. Today, there are 2 main ways of extracting geothermal energy from the Earth. The traditional approach is to find a hot, permeable aquifer and to bring that water to surface in much the same way you'd produce oil or gas. The main reason this approach to geothermal energy development has not succeeded in most of the world is that the required geological conditions don't exist in very many places. The alternative approach is a closed-loop system as championed by Eavor. A working fluid circulates in isolation from any reservoir, meaning no fluid exchange and no need for that hard-to-find permeable aquifer. A natural thermosiphon drives this system so there is no pumping required. In addition, there is no fracking, no induced seismicity, and no greenhouse gas emissions. A benefit to hot countries with water shortages specifically is that with an Eavor loop system, there is minimal continual water use, no produced brine, and thus no water treatment required. In addition, the Eavor loop's very low land footprint compared to wind and solar means it's perfect for cooling in high-density areas like Japan or Singapore. All of this results in 80% lower operational costs than traditional geothermal, as well as enabling thermal output to be accurately predicted prior to construction. This helps to reduce project cycle time from 5 to 10 years down to just 2. Lastly, an additional benefit over traditional geothermal is that the Eavor loop system can be operated in either a base load, otherwise known as constant mode, or in a dispatchable and flexible mode to blend or pair and complement intermittent renewable energy sources such as solar. Eavor's brand of geothermal, the Eavor loop, is meant to support, promote, and improve the effectiveness of solar energy, not to replace or compete with it. Most importantly, it finally makes geothermal a scalable, renewable energy source that contributes to energy independence. The Eavor loop system consists of 2 wells drilled to the target depth. A radiator section is then built by drilling and connecting successive lateral pairs. A number of different configurations are also possible. Several different factors from the market to the subsurface and surface environments are taken into consideration for the design of each Eavor loop system. The resulting systems will have an operating life of between 30 and 100 years. Strange as it may seem, you can take heat out of the ground, send it through a heat exchanger, and then into an absorption chiller to create chilled water, which can then be used for district cooling, cooling greenhouses, data centers, and much more. Currently, most district cooling networks in hot countries are typically powered by gas or diesel. There is an opportunity to replace that diesel and gas-powered cooling source with geothermally cooled water generated by an Eavor loop. On average, 40% of data center energy consumption is for cooling. Geothermal cooling using Eavor's closed-loop system would help to decarbonize the energy footprint of data centers. In places where the average temperatures are very high, greenhouses would also benefit from Eavor loop cooling. In addition, as plants actually consume CO2, using an Eavor loop for greenhouse temperature maintenance potentially results in a carbon-negative footprint. There are also many electrically powered air conditioners, and geothermal cooling could be used to replace those systems with similar capital costs by using a single centralized unit. We believe Eavor is uniquely positioned to assist countries and companies in the world to meet their cooling challenges, whatever they may be. We'd like to invite you to work with us and become a part of this solution, a part of Eavor's efforts towards the energy transition. Thanks for watching. If you'd like to learn more about the Everloop technology or want to discuss your project in more detail, please contact us at info@eavor.com or visit our website. We look forward to hearing from you. Energy forever.